Good afternoon. Before we discuss the intermolecular forces of attraction, we will have a review on chemical bonding and polarity. I am also encouraging you to please review on drawing your Lewis structures. It can help you later on. So let's start. First, let us talk about chemical bond. So what is a chemical bond? It's a lasting force of attraction between atoms, ions, or molecules that enables the formation of chemical compounds. So the key word here in chemical bonding is the lasting force of attraction between atoms, ions, or molecules. So basically, when you talk about chemical bonds or chemical bonding, you are talking about intramolecular forces of attraction. So say for example, we have your hydrogen chloride compound. In aqueous, it's hydrochloric acid, right? So here we have your hydrogen chloride compound. So the bond between the hydrogen and the chlorine atom, this is the chemical bond. So the thing or the lasting force of attraction that bonds or binds these two elements, that is your chemical bond. Okay, I hope that is clear. Ayan. So the chemical bond may result from the electrostatic force of attraction between oppositely charged ions or through the sharing of electrons. So you can have a chemical bond by having two oppositely charged ions or by sharing the electrons. So basically, you have two types of intramolecular forces or chemical bonding. That is your ionic bonding and your covalent bonding. So just a short review because I know you're already familiar with this because I believe it's been discussed since junior high school. Okay, what is an ionic bond? An ionic bond is a type of chemical bond formed between two oppositely charged ions by the transfer of electrons. So, pag ionic bond, ang keyword natin is transfer of electrons. It is a bond between a non-metal and a metal. So, you have a metal and a non-metal. So, ang technique here is, if you are familiar with the classifications in your periodic table, kung nasaan ang metal, ang non-metal, ang metalloids, so, titingnan mo lang yung location ng element, no? Kung metal ba siya or non-metal ba siya. And you can identify whether it's a covalent bond or an ionic bond. So, in the case of ionic bonding, it's a bond between a metal and a non-metal. So, say for example, you have your sodium chloride compound. Si sodium plus or the sodium element, saan mo ba siya makikita? It's on the far left side, and as you go through the periodic table, as you go to the left side of the periodic table, the metallic activity of your elements increases. So basically, kung nasa left side, it is a metal. Kung nasa right side, it is a non-metal. Ayan, para mas mabilis nyong makuha. So pag si chlorine or yung chloride atom natin o chloride ion natin, tiningnan natin sa periodic table, siya ay nasa far right side. So, siya ay non-metal. So, kapag nakita mo na yung compound is made up of a metal and a non-metal, automatic, it's an ionic compound. So, if you're going to look at this one, I hope you still remember the Octet Rule, no? So, sabi kasi natin, pag ionic bonding, there is transfer of electrons. So, if you do the electron configuration for sodium, the valence electron of sodium is 1. So, I'll just write here valence electron 1. Kapag naman si chlorine atom, ang valence electron niya is 7. Ayan. Okay, so paano ba nangyayari yung ionic bonding? So, sabi natin sa Octet Rule, in order for our elements to be stable, they have to have a valence electron of 8. So, yun ang ini-aim ng ating mga elements. Magkaroon sila ng valence electron ng 8. So, if you can't remember anymore kung ano yung valence electron, it is the outermost shell, di ba? Your valence electron is located at your outermost shell. Okay, now, if you're going to look at this one, this example, ayan, so 3s1, so 3s2, 3p5. So 7 ang valence electron ni chlorine, si sodium again, 1 ang valence electron niya. So para maging stable si sodium, it has to transfer, ayan, its outermost electron. So it has to transfer this outermost electron to the chlorine atom. So once it transfers that 1 electron, your sodium becomes positively charged, and your chlorine accepting that 1 electron becomes negatively charged. So kapag nag-transfer si sodium atom ng isang electron papunta kay chlorine, anong mangyayari? Ang outermost shell niya ay magiging ilan? It becomes 8. Ayan. So it has now 8 electrons on its outermost shell. Si chlorine din, since nag-transfer ka ng isa, it has now 8 electrons as well. Ayan. So this is an example of ionic bonding. In ionic bonding, there is transfer of electrons to achieve a valence electron of 8. Very easy, diba? It's very easy. And it is very easy. Anyway, okay, now we go to the second type of intramolecular force or chemical bonding. We have the covalent bond. So a covalent bond is a type of chemical bond formed by the sharing of valence electrons. So kung sa ionic bond, nagta-transfer ka ng electrons to achieve the octet. Sa covalent bonding, they share the electrons to achieve a valence of 8. So this is a bond formed between non-metallic elements. So kung si ionic bonding is from metal to non-metal, si covalent bonding is from one non-metal to another non-metal. So what are the examples of this? You have your ammonia, your methane, your water, your hydrogen chloride compound, and oxygen and nitrogen, no? Okay, let's talk about bond polarity. So far, we have already reviewed the two types of bonding. We have ionic and we have your covalent bond. So again, pag ionic bonding, there is transfer of electrons. Kapag covalent bonding, there is sharing of electrons. Okay. So there are two types of covalent bonds based on polarity. We have the polar and the nonpolar. Polar and non-polar. So what is the difference between the two? So if you're going to look at this one, these are pictures ng bear at saka penguins na nag-arm wrestling, no? So parang ganun lang din yung analogy ng bond polarity natin. So if you're going to look at this one, this second picture right here, so you have a bear wrestling with another bear. So assuming that their strength is equal, so mahihirapan yung bawat isa, no, na patumbahin yung arm nung isa. And kung yung penguin, same goes. Ganun din, di ba? Assuming that they have equal strength. And if you're going to look at this one, on the first picture, yung penguin is may ice cream siya, and yung bear is kumakain siya dun sa ice cream. So, assuming na naghihilaan sila doon sa ice cream, so, kanino kaya mas mapupunta yung ice cream? Siyempre dun kay bear, because obviously the bear is stronger than the penguin, diba? So, this somehow represents your polarity. So, alin ba dyan yung polar bonding and non-polar bonding? Okay, next slide. Okay, electronegativity, as you can recall, is the ability of an atom to attract towards itself the electrons in a chemical bond. So if you're going to look at this electron density map, I believe this is the electron density map for your hydrogen chloride. So if you're going to locate them in the periodic table, if you can still recall, as you go upward and to the right, the electronegativity increases. So if you're going to locate these two elements in the periodic table, your chlorine is on the far right side, which means it is more electronegative. And when you say it is more electronegative, mas hinahaltak niya, mas ina-attract niya yung electrons papunta sa kanya. So if you're going to look at the electron density map, mas malaki yung region nung ating chlorine side, indicating that it is attracting more electrons to itself. Okay. So what is a polar covalent bond? A polar covalent bond is characterized by an equal sharing of electrons between two atoms. So let's write that here, an equal sharing. So if you're going to look at this figure, so on the left side, there are 2 people, and on the right side, there are about 7 people. So if they're going to play tug of war, since mas madami yung nasa right side, the tendency is the rope would be pulled more towards on the right side. This same goes with your polar covalent bonds. So say for example, we have here your hydrogen chloride compound again, and you have here the electron density map. If you're going to look at this one, mas bulky na naman sa side ng chlorine. Why? Usually, you get covalent bonds when there is a more electronegative atom. Since chlorine is a more electronegative atom, the tendency of chlorine is to attract more electrons towards itself. So, there is an equal sharing of electrons. Kasi yung electrons, mas hinahaltak ni chlorine papunta sa kanya. Thus, chlorine will get the partial negative sign and the other atom will get the partial positive sign. Later, we'll discuss what it means to have a partial negative and partial positive sign. Now we go to nonpolar covalent. Kapag nonpolar covalent bond, there is equal sharing of electrons between two atoms. So if you're going to look at this picture, so there's another boy here, nakat lang siya, no? And there are 3 people here and there are 3 people here. Assuming that both sides exert the same force, the same strength, so the rope would just go a little bit to the side and then another to the side. So naghihilahan lang sila, pero wala talagang pinupuntahan na specific side yung rope kasi they exert the same strength and they exert the same force. So again, pag polar, there is an equal sharing of electrons. Pag non-polar, there is equal sharing of electrons. Now let's talk about partial charges. So partial positive means less electronegative, and partial negative means more electronegative. So basically, you assign partial positive and partial negative charges to a sign who is more electronegative and who is lesser in electronegativity. So para mas madalian kayo, to make things easier for you, if the element is situated at the far right side of the periodic table, it gets the partial negative sign. If it's situated at the far left side of the periodic table, it gets the partial positive sign. So if you assign the partial negative sign to that element, that only means that element is more electronegative than the other. So in this case, the chlorine atom pulls harder on the electrons, and the electrons spend more time near the chlorine atom. Why? Because your chlorine atom is more electronegative than the hydrogen atom. Now let's talk about dipole. A dipole is a molecule with 2 poles with opposite charges. Polar bonds or molecules have one end slightly positive and the other slightly negative. So usually, ang mga polar molecules natin, they have dipole moments. Dipole moments, or some people call it net dipole. Okay, let's discuss that further. So in the case here, we have your hydroxide. So OH negative, and here is the electron density map. If you're going to locate them in the periodic table, hydrogen is on the far left side, so it gets the partial positive charge, and your oxygen is on the far right side, that's why it gets your partial negative charge. So your oxygen atom, since it is more electronegative, its tendency is to attract more electrons to itself and pull more electrons towards itself, and the electrons would stay here, no, on this side. The question is there a dipole moment, or is hydroxide a dipole molecule? Yes, it is a dipole molecule. Why? Because it has a dipole moment. Pag sinabi nating dipole moment, there is a specific direction kung saan pumupunta yung electrons ninyo. In this case, here you have your partial negative sign and your partial positive sign. Since in this case, oxygen is far more electronegative, the tendency is that your electrons from the positive, partial positive, will go to the partial negative. So there is a dipole moment. So automatically, if there is a dipole moment, your molecule is polar. I hope that is clear. Such as in the case of your hydrogen chloride molecule. If you're going to look at this one, we know that this will get the partial negative sign and this will get the partial positive sign. So, saan mas papunta yung electrons ninyo? Papunta siya saan? Papunta siya doon sa partial negative direction. So, papunta sa chlorine atom natin yung mga electrons natin. So, there is a dipole moment for your hydrogen chloride molecule. So, that means this molecule is polar. Automatic, if there is a dipole moment or a net dipole, automatic, the molecule is polar. Automatically, the electrons are unequally shared because there is a specific direction wherein your electrons are being pulled at. Okay, polarity of a molecule. Okay, for a molecule to be polar, it must have polar bonds. It means there should be an equal sharing of electrons. Number 2, this can be determined from differences in electronegativity. So you can actually determine whether a bond is polar or non-polar by looking at the differences in electronegativity. There are specific range of values that lets you know whether it's non-polar, polar, or ionic. So, number 2, for it to be polar, it has to be an asymmetric molecule. We'll delve deeper into that later. So, when we talk about symmetry and asymmetry, we talk about the molecular shape. Okay, the more different the electronegativity of the elements forming the bond, the larger the electronegativity difference, the more polar the bond is formed. So, mas malaki yung electronegativity difference ng mga elements mo from each other that is forming the bond, mas polar sila. Ayan. Polarity is a measure of the inequality in the sharing of bonding electrons. So, I wouldn't delve deeper into that. That is self-explanatory. So, this is just a trend on electronegativity, as I've mentioned earlier. As you go upward and to the left, the electronegativity increases. So the most electronegative atom in this case is your fluorine. Yeah. So classification of bonds by difference in electronegativity. So if you get a difference of 0 to 0.4, that bond is nonpolar covalent. You can get the electronegativity values in the periodic table. It's actually indicated there. In this case here, these are the electronegativity values for your elements. Yeah. And if you're going to look at this, the highest really is fluorine. It has an electronegativity value of 4. So you have 0 to 0.4, that is nonpolar covalent. If you get a difference of 0 to 0.4, that is a nonpolar covalent type of bond. 2 or greater, that is ionic. 0.5 to 1.9, that is polar covalent. Very easy now. You just have to remember these values. But if the electronegativity values are not given to you, Again, if the electronegativity values are not indicated or not given to you in the problem, you can simply tell whether it's polar or non-polar by looking at what? The bond, the elements, no? Kapag metal to non-metal, automatic it's polar. Kapag metal, non-metal, if you have a non-metal to another non-metal, automatic that is non-polar. So increasing difference in electronegativity value, ayan, from non-polar, you go to polar and then to ionic. So classify the following bonds as ionic, polar, covalent, or covalent. The bond in cesium chloride, the bond in water, and the end-to-end bond here. Okay, so we have here for cesium, the electronegativity value is 0.7, and chlorine is 3.0. The difference would be 2.3. So this is what? If it's greater than 2, it's ionic. And very easy. Next, hydrogen is 2.1, oxygen is 3.5. The difference is 1.4. So this is what? This is a polar covalent compound. Very easy. And if you're going to draw the structure of water, ayan, di ba ganyan ang structure ni water? Meron siyang net dipole, kung titingnan ninyo. Kasi, since this oxygen is on the far right side, this gets the partial negative sign. Ayan, partial negative sign. And this too will have the partial positive sign. So, saan papunta yung electrons? Hinihila sila papunta doon sa oxygen atom. Ayan. So, basically, the electrons are being pulled upward towards the oxygen atom. So, there is a net dipole. Meron siyang dipole moment. So, sabi ko nga, di ba, pag may dipole moment or may net dipole, automatic, that is what? That is a polar compound. Polar molecule, sorry. So, here, nitrogen, the bond between nitrogen and nitrogen, so 3 minus 3, that is 0, so that is non-polar. Which makes sense din naman because N, nitrogen, is a non-metal. Bond with another non-metal, that is what? Non-polar. Yeah. So we have here the hydrogen molecule. So we have a electronegativity of 2.1. So if you subtract 2.1 to 2.1, that is 0. So that is non-polar. Ayan. It is non-polar. And hydrogen, H2, hydrogen particularly is a non-metal. So again, if it's a bond between a non-metal to a non-metal, automatically that is what? Non-polar. So you don't really actually need the electronegativity difference. By simply looking at the periodic table where the element is situated, you can already tell whether it's polar or non-polar. Yeah. And ionic actually. So, hydrogen chloride molecule. So, we have here 2.1 and 3.0. If you subtract it, it's 0.9. So, nasa range siya ng polar. Ayan. So, this is a polar molecule. And there's a dipole moment, no? So, here, we have here the sodium chloride. So, the electronegativity of sodium is 0.9. Electronegativity of the chlorine atom is 3.0. If you subtract that, you get a result greater than 2. So that is an ionic compound. So there's no molecule.